get the show on the road. At the end of the last lesson, we spoke about something called a surd equation. And so I want to start this lesson with a surd equation continuing from where we left off. But before we do that, I want to talk a little bit about strategy. So when we deal with a surd equation, there's three important steps that we normally think about. And I'm just wondering if any of you kind of can remember those steps from class. What's going to be an important first step in the process of solving a surd equation? Does anybody remember from class? Like your teacher might have. So step one is going to be to isolate the surd. Step two is going to be to square both sides. And then the last step in a surd equation is also to always check your answer. Okay, so that is the decision-making guidance that you will need for this question. I'm going to hand over this question to you. And if there are comments or questions about this, then I'm happy to answer them. But that's the amount of guidance I'm going to give you as you engage with 1.1.3. Okay, off we go. Let's see if you can solve this question. I'll get some water now. So keep those answers coming when you've I would call that step one, because you've isolated the surd. You've got the surd all by itself. And so that helps you deal with the surd in step two. Step two was to square both sides. And if I square both sides, it basically means I'm doing that. That's great news for getting rid of the surd, but it does introduce a bit of complexity with expanding this binomial. And there's two ways you can expand the binomial. You can multiply it out by writing x minus 3 times x minus 3, which is what it means. Or there's a shortcut, which I'm going to use, where you square the first term, you then times the first term times the second times 2, and you square the last term. And it will end up being the same amount. So that is that part. Then you have to obviously put it in standard form. And so you'll get, well, let's do all that. So minus 7x plus 10. And then I need to be able to factorize this trinomial, or I can use the formula. So you have two choices. The one is to write that a is 1, b is minus 7, c is 10, and use the formula. Or I can see I can factorize this, and that's obviously because I've done this many times. And then and that is, the more you factorize trinomials, the better basically you get at them. But you should get exactly the same answer if you use the formula. So 0 equals x minus 5, x minus 2. So therefore, x is 5 or x is 2. Now, it turns out that that is not done. Normally in an equation at this stage, you are done. But in surd equations, you are not done because you still have to do something called the check. So what is the check? You have to make sure that if you put your answers back into the original, they make sense. So what I do is I say, okay, well, I'm going to check 5, x is 5. And if I go back to the original, 5 minus 1 is 4. Square root of 4 is 2. 2 plus 3 is 5. And the right-hand side is 5. So the left-hand side does indeed equal the right-hand side. It makes sense. So that answer is fine. Yes, Lesejo, I see you've raised your hand. You want to unmute Lesejo and then we can have a question?
So,
yeah.
Haven't you made a mistake in saying that? Oh wait, I forgot to account for the 9. Never mind.
Yeah.
Never mind. I thought you made a mistake with the clearing up of the log terms.
No problem. I do sometimes, so it's good to be on the watch out for that. But I think in this case, we're good. Okay, now when x is 2, if I go back to the original and I go 2 minus 1 is 1, the square root of 1 is 1. 1 plus 3 is 4. So the left-hand side is 4, but the right-hand side is x, which is 2. So the left-hand side does not equal the right-hand side. And so we reject x is 2, and the only answer is x is 5. And so that is an example of the surd. It's not, I wouldn't say it's much harder. It does have this initial step where you have to isolate the surd, square both sides, and then the check at the end. Okay, Shoshana, x is 5. Who else? Yeah. So are there, I know I went a little bit fast there. Are there any questions or comments from the class that you would like to clarify, or any step that I lost you at before I move on? Give me a thumbs up if things are feeling okay for you. Thumbs down if you feel a bit lost. Just want to know how the people in the room are doing, since I don't see your lovely faces all the time. Okay. Then we shall continue going on. So what I'm going to do is I'm actually going to find you another surd equation just so we can really make sure we nailed this. So you'll notice I'm jumping around from previous past exams just to show you the structure is pretty similar. So I want you to solve the surd equation over here. So you solve for x. I can tell it's a surd equation because of the square root. And I want you to solve that for me. So over to you guys. I will take questions from the room, but otherwise it's time to swim solo.
You can do this, guys.
Yeah, boy. Yeah, boy, yes. So if I move these around, minus 2x minus 1. So I get x squared minus 4x. So when I factorize this, yeah. Oh, that's nice. I didn't even have to factorize a trinomial. So I get x is 0 and x is 4, but I'm not done. I still have to do my check to see that things are going well for me. So let's just check x is 0. If x is 0, if I look at 2 times 0 is 0. 0 plus 1 is 1. The square root of 1 is 1. So the left-hand side is 1. But the right-hand side is 0 minus 1, which is, so that actually isn't equal to each other. So I have to reject the solution. And let's try x is 4. So 2 times 4 is 8. 8 plus 1 is 9. The square root of 9 is 3. And then 4 minus 1 is 3. So all is well with the world here. And so the answer is just going to be x is 4. I'm going to say just that one. I'll reject this one. Yeah. So the good news is it does get easier with time. So just thumbs up if things are okay and happy. Thumbs down if you're not happy, or even we can just say, just put your hand up to ask a question, or ask a question in the chat, and I'll go over a certain aspect of this question. Okay. Then what I want to do is I want us to, I know in the last lesson we did some of this, but I really want to make sure you're solid with your inequalities. So can we quickly do 1.1.4, and I want you to solve for x with that inequality, because that's another one where we have to make sure that we are on form there. Take a screenshot of the screen if you need to, because I'm going to be clearing the board shortly. So I'm looking for my critical values. And just a reminder, this is a parabola. And so if you want to visualize what this expression looks like, it's going to look like this. And we're looking for when it's less than 0. And so less than 0 is going to be basically when the parabola is below the line. So our answer is going to be basically between those two critical values. But we need to find those critical values, which is what we're going to try and find now. I was thinking, you could also use the formula. There's nothing wrong with that. But so my critical values, kind of, we have x is 4 and x is minus 2 are the two critical values. But now I need to write the answer to this. And the answer is going to be basically where it's greater than 0, and it's actually going to be empty. It's not going to be solid. And so your answer is going to be, so x is going to be greater than minus 2 and less than 4. Basically, your zero values are going to be here and here. that's the one method we use to do it. Sometimes what can be useful is to say, put it on, instead of doing the graphic method like that, you take a number line and you put your critical values. So here's -2 and here's 4. And we can see from the graph, or we can just sub in a value greater than 4. And if we sub in a value greater than 4, this is positive. And then when it comes over here, this is negative, this is positive. And then we can see that our answer is basically that region, which is this bit here. So x is between -2 and 4. These two approaches, this is called sort of the graphical approach. This is the sign table. Both are useful in different scenarios and depending on how complex the inequality is. Right. Oh, what happened? Let's do it. Okay. Are there any comments or questions about that? No. All right. So then let us move on. What other questions? Okay. I wanted to look at, let me look at a exponential type of question. This is sort of a standard type of question. So let me change it for a moment and let me actually just isolate the one question I want to focus on. And that is going to be this question here. Next. So it says simplify without using a calculator. Okay, can everybody see that question? So this is a different type of question, and it comes from the topic of exponents, and you basically just have to simplify it, but there's a different set of rules that are involved. And I want to ask, can anybody give me some tips as to how we would go about simplifying this expression? Yeah, Shoshana, let's unmute Shoshana and we can.
I don't really remember correctly, but I think it should be dividing up the values into their prime bases.
Yeah, perfect. So in this exponential expression, the most important thing is to have prime bases and bases that are the same. So at the moment, when we deal with the laws of exponents, the laws of exponents really make a big deal about having the same base. In this question at the moment, the one base is 2, the other base is 4, the other base is 8. However, we can do some maths that converts the base from a 4 into a base that would be much more useful. And so what I want you to think about is, well, let's actually ask the class, how are we going to make all these bases the same before we can start the real work of this question? So yeah, they're all powers of 2. Love it. Love it, Dawn. So if you think about 2 is just 2 to the 1, but then 4 is 2 to the 2, and 8 is 2 to the 3. So I'm going to let you try and solve this now, but just my tip to you is convert the bases to be prime numbers that are as much as possible the same base. And then let's just see how you do now by yourself. And we'll go from there. And I'll come along. And what I'm going to do is I'm going to be sneaky and do it like this. Well, not sneaky. I suppose I'm just going to be, I know where bad things can happen. So I know this is a good way to write them. So there's my 4 hanging out. That's my 4. And then this is my 8. So where do we go from here? And this gets a lot of people, is that this 2 has to be applied to both of these. This 3 has to be applied to both of these. So we get that catches a lot of students. Now the good news is that the bases are all the same. And so on the top, we can simply add the powers. So we're going to get n plus 2 plus 2n plus 2. And on the bottom, we're going to get what we had. So what do we have? We have, that's an n and that's an n. So that's a 3n. That's a 2 and that's a 2, which is a 4. And then on the bottom, we have this. And there's a couple of different steps that we can use to go from here. What I think I would probably do is I would just say the bases are the same, therefore I'm going to subtract the powers, but I'm going to put that thing in a bracket so I don't make a silly mistake. So what do I get? I get 3n plus 4 minus 3n plus 3, which gives me 2 to the 7, which I, off the top of my head, 8 times 8 is 64, 128. 128. Okay, so I don't know if you had to go quite as long a journey as I just took there, but yeah, that is the process we would use. Questions or comments? All right, let's see if we can squeeze in one more. Take a screenshot now if you need to, just to follow the working. And then I'm going to find maybe one more short question before the break. Let us. Okay, from the last, is there anything that's short here? No, there isn't really. Oh, okay, let's do one from here. So what I would want you to do is I want you to simplify 1.2.1. So it says simplify without the use of a calculator. I want you to figure out this. And remember, it's no calculators and it's just 2 marks. Off we go. So obviously, if you could just put this into your calculator, it would be easy, but it explicitly says, so the moment there's no marks for the answer in this question, the only marks are going to come for showing the working out. And the key step with exponential and surds and all these things is the bases. You change the base to be convenient for what you're looking for. And in this case, the 125 can be rewritten as 5 to the power of 3. Now, this is good news because there's a law of exponents that says if you have 2 exponents next to each other, you multiply them. And I can write this 3 as 3 over 1, and it's still the same 3. And what that allows you to do is to cancel out those 3's, and you get left with 5 squared, which is 25. And so that's just checking your knowledge and understanding of exponential notation. Yeah, so Shoshana, Oratile, Romeo agrees, and yeah.
Well done, everyone.
Questions or comments? Yeah, well done. Well done. Okay, you know what time it is? It's my favorite time of the night. I want you to turn on your cameras so I can see your lovely faces. We're going to stand up and we are just going to luxuriously stretch out. Oh, let's do it. Let's do it. Let's do
Please
it.
join us in the stretch, guys. Turn on your cameras. Let's see your lovely faces.
Exactly. I'm
Shout
switching.
out to Shisana. Shout out to Lisego,
Oh,
Darren, Katlejo.
that feels good. Oh, stretch it out. Ah, my
Oh,
shoulder
yeah.
blades. Yo, my shoulder blades.
Don't miss out on this, guys.
Oh, double click. Can you hear my joints clicking? I'm like slightly alarming.
I think, are you doing it right if you get clicks? Because I'm getting clicks too.
Yeah, it's because, yeah, no, clicks are good. They feel good. Okay.
Come on, guys, don't be shy. Even if you're in the dark, don't let ESCON stop you.
The show must go on. Oh,
Yes.
do a tricep stretch. Oh, that feels fantastic.
Lisego is going way into that. He's like exercising.
No, and his body's really like revived. Oh,
Yes. You're going to feel so good after this, guys.
it's hard to, like, I'm not even joking when I say, oh my gosh, the stretching break is amazing. Amazing.
Feeling like a new person.
Oh, I do. Honestly, it's like we're such, our bodies are like, you know, you treat them right and they treat you right back. Okay,
Yes.
so I want you guys to initially solve for me the blue maths puzzle. And then, in fact, you can do both. You can do both. So let's see if you can, well, they're more of like a, not really a puzzle, I guess. It's more of a, like a thinking question. Can you solve it? So BODMAS says multiplication and division is just more important than addition and subtraction. So that is helpful. I agree with Chloe and Darren. And who else? 48. Yep. First one, definitely 48. So that is the blue one's answer. So as long as you knew your order of operations, life is good. Second one, a little bit trickier. There's a common. So this bit needs to get done first, but 3 divided by a third has definitely caught out many students in the past. There's no doubt. And it will continue to catch many students to the future. So what is 3 divided by a third? So it turns out 3 divided by a third is the same as 3 times 3/1, or 3/1, which is actually 9. And so we get 9 minus 9 plus 2, which is 2. I know it's crazy.
Job, guys.
3 divided by a third is 9. Another way to think about it is division is like repeated subtraction. And so ask yourself, how many times can you take a third away from 3? And you can take it away 9 times. So that's why it makes sense. But somehow our brains are like, why is it feeling bigger? I'm dividing. And so the answer should be 2.
Unless you do that whole tip and times thing as well.
Yeah, so that's what I often say to students. Like I say, you know, write 3 as 3/1 when you're dividing by a fraction, because it somehow your brain goes, oh, I remember that rule. So now it's, I change the operation, and then once I've changed the operation, I have to do something to change that. So I invert the second one. All right. Let us move back. But that was cool. I liked it. Just remember, sometimes simple is better. So let us stay with this current question we're doing at the moment. And I want us to do what's called a surd simplification question. Now, so you're going to do the yellow one for me. The tip I'm going to give you is that when you deal with surds, and this is a bit weird, like the square root of 2 times the square root of 3 is the same as the square root of 6. So there's this weird kind of, well, not weird, but it's just not as commonly seen as the exponential laws. And this makes sense because the square root is really just the same as the power of a half. Okay, so essentially what we have here is in exponential land, we could easily write that as that. And so see if you can use some of that idea as you try and do the yellow one now. If you need more help, I will give it to you, but I feel like that's a good enough cryptic clue for now. So you're simplifying without the use of a calculator was the question that I've kind of cut off there. And we're doing the yellow one. Yes. So I've done a little bit of multiplying, and the multiplying can be a little bit tricky. Some of you probably prefer to go straight to this step. I only showed this step because I wanted to show you literally I'm using FOIL, like I'm literally multiplying out, and I have the 4 sections that come from multiplying out like a double bracket. But sometimes when you get used to these, it's easier to just go 6 and then root 2 times root 2 and so on. The interesting part comes in, how do we deal with these parts? Well, you know, the surds essentially. And so that's what we need to get to simplify this. So root 2 times root 2 is actually the same as 2, which is wonderful because 6 times 2 is 12. And, you know, that is, there's a minus 12 at the end. So really, it feels to me like these two can cancel each other out. So all I'm left with then is I'm left with this. And these are what we call like terms. So they both belong to root 2. There's 3 root 2s, and then you lose 24 root 2s. So in total, 3 minus 24 is minus 21 root 2. This root 2 is going to be irrational because it's a squared, it's square rooting a non-square number. And so that's as far as you can go. Minus 21 root 2. Any questions or comments about that? I'll see if I can find you another one to practice this while if there's one that stands out to me. And just take a screenshot now if you need to track that working. Where is a nice, is there anything else down here? Okay, that's a bit tricky for that. Let's go to, excuse me if I'm making you dizzy, guys. I just want to go in there already. Oh, let's do 1.3 while we're here. Let's do 1.3 and then I'll go looking for more questions. So next question, 1.3. And give me the answer for 1.3.1. For which values of x will the expression be undefined? Value or values of x? So I suppose we have to ask ourselves, what does undefined, how does something get undefined, right? That's quite important. Okay, I can see in the answers, yeah. So x is 3. Why is x is 3 going to be the answer? Well, if we think about, we don't want, well, it actually says for which values will be undefined. And the expression will be undefined when the denominator is 0. If that's 0, it causes this whole fraction to be undefined. So when does 3x equal 9? And basically the answer is x is 3. So when x is 3, the expression will be undefined. Okay, now I want you to simplify this expression for me. So you're given this whole expression. What is it, if you simplify it, what is the answer going to be? Over to you guys. To think, what tools do you have in your tool belt? If you want to simplify expressions, feels like factorizing may be your friend. So I can actually see that the bottom has a common factor and the top feels like a trinomial. 3 and 2. Let's check. X squared plus 2x minus 3x and 6. Yeah. So now, if I factorize the top and bottom, how would I simplify it further? What do I need to do to simplify it further? Well, I can notice that there's a common, well, there's a factor on the top and the bottom that's the same. And what we say is anything over itself is the same as 1, or if essentially we cancel that. And then we're left with x plus 2 over 3. And so that's a pretty standard technique in algebra. Yeah, so Romeo, Fagelo, Chloe, Shoshana, that's looking good. X plus 2/3. Yeah.
Nice work, everyone.
Big up. Like it. I like it. Okay, let us go looking for something a little more. Let's go to the next old question. Here we go. Let's go to one of these ones. We'll finish with this. Well, this group of questions. I want you to simplify fully without using a calculator this expression. But before you go off on your quest, I want the class to think about, this is a different type of question. And I want to ask for some tips from the class as to what techniques might be helpful, because this is different to the previous question we did like this. There's some subtle differences. Maybe you can even spot them first before we start. Maybe somebody can come online and point out what they notice is different before we head off. Because a lot of being good at maths is having an idea of where you're going before you go there. And so recognize what is different about this question compared to the previous one, which was with the twos. When we had then we have 4 was 2 to the power of 2, 8 was 2 to the power of 3, and we simplified. This looks a bit different. Yeah. Lesejo, yeah.
Sir, there is a -3, and since 3 is a prime number, you can't necessarily bring it down to a prime factor.
So the three is definitely the odd one out. And then it's the subtraction. Yeah, the fact that it's not all a multiplication, there's actually a minus between those two. And so the way we can do this, we actually have to use a different technique. And so the technique is going to be that we use the technique of a common factor. Okay, so that's my tip. See how far you can get. I'll give you more tips in a moment, but there's going to be the use of a common factor to solve this type of expression, or simplify it rather.
Mr. S, Shisan is asking if you can please zoom in a little bit.
The magic of vectors, I can do just that. Yeah. I'll give you that tip. This is a good one. This is a good question. But for those who are finding this a bit tricky, ask yourself, what has to go here in order that when I multiply it out, I get back to this one? That's what you want to think about. What do you have to multiply by to get there? And yeah, if you do have a question, I'm going to say that it should be this. Think about if you agree with me. So just to test my own logic, if I multiply these two together, the bases are the same, which is good because I can use the law. And then I have that. Yeah, so seems good. the next one, -3, because I've got to use that. But there's also going to be a 2 to the power of 1. So that's the top bracket. Then the bottom, what I really want is for this 2x to be separate from this over here. And the good news is because I understand my bases, I can actually split these like that. And so now what I really love about this is I've got a 2 to the x on the top and a 2 to the x on the bottom. And so I can cancel them out. And then I'm just left with, okay, there's still a bit of math to be done. So let's see what I get. 2 to the -3 minus 6 over 2 to the -2. Without using a calculator. Okay, so this is where I'm going to be a little bit, I'm not sure if they want you to go quite as thing like this, but 2 to the -3 can be written as 1 over 2 to the power of 3. And so I make it a positive power. And over here, I get 1 over 2 to the 2. Okay, now I'm really going to show you my knowledge of fractions, but I'll have to check the answer in a moment. You basically get down to that. And look, to be fair, at this point, they're not really going to be able to check all, well, I suppose they would. So then I'm going to put these two fractions together. So what do we have? 6. If I wanted to make that, 6 is the same as 48 over 8. I'm using and so then I get -47 over 8. And if I want to divide by a quarter, it's the same as timesing by 4 over 1. And so 4 goes into 8 twice. And I get -47 over 2. Okay, so if you're not, that last bit was a little bit like, it wasn't horrible, but I suppose people just don't use fractions as much. They tend to default to their calculators. And so it's good to go back and see what I did. Let me just quickly go through it. The negative powers tend to make life a bit difficult. So what did I do? I rewrote them as 1 over 2 to the 3 and 1 over 2 to the 2. Then I went back to normal numbers because that's also easier to deal with in terms of evaluating. The big problem I had was 6 was being uncooperative. So what I did was I said, well, how do I make 6 have a denominator of 8? And I can write 6 as 6 over 1. And then what I did was I just times the top and bottom by 8. And that's how I got my 48 over 8. Then I went, awesome, denominators are the same. So it was -47 over 8. And then I used my top and times thing, like dividing by a quarter is the same as timesing by 4 over 1. And then I got there. And that you get from just being very comfortable with fractions. Okay.